Hello everyone and welcome to the session. I am Niraj Lunavat. I really appreciate you all for taking some time to join us for this event today, and we sincerely hope you and your families are doing well. This has been one crazy year, and this is the second session of the Artificial Intelligence India community. So at AI India community, our goal is to help you to learn artificial intelligence and data science by making some world class AI resources and education accessible to everyone. With that, we aim to empower you. Part of that work, we arrange meetups. Our community is of aspiring and current machine learning practitioners to be the part of AI transformation that's happening across so many industries. And this is the second meetup of the community. We have very special guest today. We have Dr. Satya Mallick, CEO of OpenCV. His blogs at learnopencv.com are very famous, which makes him one of the most influenced AI geek on the planet. He wears multiple hats. He's the CEO of two companies. He's the researcher, developer, blogger, and in the true sense, he's a real computer vision geek. With this, I would like to welcome Dr. Satya Mallick. Welcome, sir. Welcome to the session.
Hi Niraj, glad to be here. It's very good to connect with the Indian community, and thanks for putting this together.
Pleasure is mine, sir. With my invitation, you came and sharing the untold story of the OpenCV with us. Thank you so much for that. We all are quite excited to know your journey from the starting, from the very beginning, especially IIT memories, and and how was those days? What was your vision to become at that time?
Well, so I grew up in India, in many small towns in India. My dad was a doctor in border security force, so I traveled a lot. He used to get transferred every year. Like in Hindi movies, you see, right, that you don't get along with the boss, transfer ho gaya. So that used to happen to my dad. He used to get transferred every year. But the bright side of that was that I saw many places in India. So I've traveled. I was in Bengal. I was in my native state, Odisha. I traveled to the northeast, Meghalaya, Manipur, Mizoram, etc. So and then I've also traveled to the western part of India, like Punjab. My dad was posted in Punjab, and so it was, I got a taste of different cultures within India. And growing up, it was like a very normal Indian family. It was a standard middle class upbringing where a lot of emphasis was on education. That was it. You spend all your time in making a good career. That was the primary thing. But like all the kids, we also played cricket and we played soccer when that time was right. So in that sense, growing up in small towns, I did not really have much pressure, family pressure. But in the sense that you just be first in class and that's okay. That's all. Koi pressure nahi hai. But after my eighth grade, my brother, and I, we moved to Cuttack, Odisha, which was my hometown, because the cities that I was staying at, they were small cities, and because my parents wanted to make sure that we get a good education, we moved to this place. We moved to Cuttack, which at that time, for us it was a big city, but it is actually a small town as well. So we moved to Cuttack for our education. I went to I did my 9th and 10th grade in Kendriya Vidyalaya or Central School, and then I went to Ravenshaw College, Cuttack, which is in Odisha. And in Ravenshaw College, it is one of the few places where the 10+2 was in a college environment, right? It was not a school environment. It felt like college already. So that was an interesting thing. And after that, the last 2 years after 10th grade, I started preparing for IIT, and From Cuttack, there were not very many people who had actually cracked IIT. In fact, when the year I was appearing for JEE, 10 years before that, only 6 people had actually cracked the JEE. Only 6 people from entire Cuttack had had cracked JEE in 10 years before me. And so it was, you keep thinking that, oh, I'd never seen an IITian before. 1 year before me, there was one senior, Sunil Patro, who got into IIT, and he was like a local celebrity. We went and I actually talked to him for half an hour, and that was inspirational because I had never met an IITian before. And I talked to him, and the goal was not to know what materials to study, okay? Because I already knew what to study. That was not the goal. The whole point of meeting Sunil was to see somebody who had actually cracked IIT. I had never seen anybody. And the second person who I knew went to IIT, I knew him very intimately because that was me. So the next year, I got into IIT, and there were not only that, there were 6 other people in this. There were, I think, 4 other people who got into IIT in the same time as me from Cuttack, which was very unusual. I mean, in the last 10 years, only 6 people had got through. But in that year, I think 4 of my friends, three other friends, and 2 other people who I did not know got through IIT also. And the funny thing is that all 4 people that I knew actually went to see Sunil Patro, right, before that. And it is one of those things that you get inspired by just watching people succeed right before you, and it breaks the mental barrier. So that is what happened, and that was pretty much my childhood until the 12th grade.
Okay. Good to know. Like, how's the memories at IIT Kharagpur, and how were those days? And as I know, after completing bachelor's from IIT,
Right.
You got admitted to the University of California, San Diego.
Right.
And how was the journey from India to USA? And can you share some Ph.D. memories at University of California, San Diego?
Yeah. I'll come to that. There is one other memory I wanted to share before the IIT days. And that's very important because, when you're a youngster, it is very important how you interact with your parents, how you interact with other people, to understand what path life would take you on. And it's very important to understand that your parents will not always be right about the decisions you make. So my story from the 12th grade was, in 12th grade, my father was a doctor in Border Security Force. So there was this enormous pressure for one of us to become a doctor, right? My brother or me had to become a doctor, and my brother, who's older than me, he had already become an engineer. So the pressure was on me to become a doctor, a medical doctor. And I actually did not want to do that. In fact, what I did was, in 12th grade, I decided to not take biology. So I had taken biology as the 4th optional. They used to call it 4th optional. We had physics, chemistry, and mathematics. That was compulsory. And the 4th subject that you had to take was optional. You could take either electronics or biology or statistics. And there was status associated with each one of these. Electronics was the high status, and I missed electronics. There were fewer seats. Most of the people took biology after that. And then statistics, for some reason I don't know, it was considered, you did not get into biology, and therefore you went for statistics. And so there was this pressure. I did not want biology. I wanted to take statistics, but statistics was considered low status, right? For some reason, it's very difficult to explain, but statistics was considered low status. So when I went to change my biology to statistics, the clerk would not let me do that. He said that you are ruining your life. You are not, your chances of getting into medicine go to zero. And what does your father do? I said, my father is a doctor. He would not let me change from biology to statistics. He said that you have to get your father and then we will talk, right? So next day I get my father to this office, and now both of them are lecturing. The whole office, you imagine, I'm 16 years old, and this office full of like 10 people around me, they have gathered and they are lecturing me how it is a bad idea to change from biology to statistics. And I did not, I held my own. I kept arguing with everybody. And then finally I turned to my father and said, look, if my engineering chances are ruined because I take biology, because biology it required a lot of effort. You had to actually, there were these very big books that you had to study for, one for zoology and one for botany. And it was not trivial to, actually compete in both medicine and engineering. Pick one and go for it, right? So I decided that I'm not going to do that. And I said that if something goes wrong, you'll be responsible. So then my dad backed off. He said, no, okay, I'm not going to force you. You pick whatever. So I picked statistics. And the funny thing is that because I picked statistics, and statistics was easier than biology, because once you get the fundamentals of statistics right, you don't need a lot of preparation. You can go to the test and crack it if your fundamentals are good. In biology, you cannot do that. In biology, it's about knowledge. You have to read. If you don't read, you cannot. There are these books that you have to absorb. There's no conceptual thing, right? You had to know things. In statistics, there were conceptual things that even if you did not read the whole syllabus, you could actually derive a lot of things on the fly. If you were good, you could do that. And so it turned out that I was in the top 20. So the Odisha board used to release top 20, a list of top 20 people in the state in a higher secondary exam. So I was the 17th and I did not prepare much. Statistics, I literally read statistics for 1 hour for 30 days right before the exam. And before that I had not even, I used to go to the classes and that is it. That was my preparation. And in statistics, I almost got full score, in both papers. And because of statistics, I was the 17th in the state. If you remove statistics, then I would be nowhere, right? Because I was not preparing for the board exams. I was preparing for IIT. So that is one thing that you have to be careful about when you're young. People will try to put pressure on you, but it's your life. You have to make the decisions for yourself. And later my dad used to say that it is actually a very good. What I did was very good. He was proud that I stood on my own, right? I could take on these 10 people who were in their 40, 50-year-old people trying to advise me. So you have to take your own decisions in life, and if the decisions are wrong, they are wrong. You are responsible for it. So that is something I learned very early on in life. This was when I was 16. That don't worry too much about what people think, because their way in life is very different from what your way in life would be, right? They cannot advise you. Even your parents may not be able to advise you what is right for you, because their experiences are very different. And sometimes, these things have moved on. The technologies have moved on. The concepts have moved on. They cannot advise you. So that's one thing I learned. Now coming to life at IIT. Actually the first thing that I realized in IIT is that there are these two kinds of people. One is called a Maggu, the other is called a stud. There were these two kinds of people who did well in academics. And there were, even in IIT, there were like about 50% of the people did not care about academics at all, right? They had cracked the IIT and that was it. For them, they had won and they were not going to work anymore, right? But the fact is that that's just a stepping stone. You just got into IIT. That's the start of your career. You're not that's not the end of your career. That's not the best thing you have ever achieved, right? So, but a lot of people start thinking that, oh, I'm done with, I cracked IIT and that is it, right? That is the best thing I'm going to ever achieve. And they stop trying, which is very, it's kind of disturbing. But the people who did do well in academics, there were two categories of people. One was Magoo and the other was Stud. The Stud was a person who didn't have to try much and they still did very well in academics. And Magoo was the person who had to try very hard, right? And I was a Magoo. I was a Magoo. I always had to try very hard. And there is no shame in that. There is no shame in that because ultimately nobody cares how much effort you have to put in for your success. The only thing matters is whether whatever you are doing, whether you're good at it or not, right? Whether you spend 10 hours to achieve that or whether you spend 20 hours to achieve that, nobody really cares, right? And one other thing I noticed was that all the people who we used to think as studs, they had very good short-term memory, right? So they could read something and do very well in exams. So they could do very well in exams, but after the exam, it was completely wiped out from their mind. The concepts did not stick to their mind, right? So now, if you ask me about, how a DC motor works, I can explain you very well because I took this concepts very slowly, right? I understood it. I spent time with it. It became internal, and there is no shame in that. Spend the time because it's not easy to grasp all the concepts. Spend the time to understand, build the foundation strong. And I know that a lot of people who I used to think at that time, they are really smart because, it took them so little time to understand something that took me a long time. But now I look at them and they actually did not get the concepts well. So they did very good in academics, but they did not get the concepts well. And that is something you should never pursue, right? When you dig deeper into any subject, when you build a solid foundation, then you start appreciating any field you enter. It is not just, I used to get a lot of joy in even electrical machines, which was considered very uncool at that time, right? Because computer science was the big thing, right? Computer science was the cool thing to do. And this other thing was not as cool. Electrical engineering, big machines, 440 volts of connections, etc. That was not considered cool. But if you dig deep into it, how the machine is working, how the three-phase motor works, then you start appreciating, wow, this is quite remarkable, right? The concepts are quite remarkable. And those things actually help you in the long run, right? You start appreciating the knowledge itself instead of reading for a career, right? The people who were only interested in computer science were reading for a career. And in fact, they did not even develop very good understanding, very good knowledge of computer science. They did not appreciate learning for learning's sake, right? And that is very, very important. To really enjoy that you have learned something new, maza aa raha hai. That feeling, if you don't get, then you don't go far.
Hey, this is quite inspiring, And one of the learning here is that not to take pressure of anything if things are not in your favor. So how was the journey from IIT Kharagpur to University of California, San Diego campus? How it started? And one of the asked question on the forum is that I would like to add here, whether Ph.D. is really beneficial for career in the artificial intelligence. What is your take on this?
So the first thing is that from IIT I graduated and I came to University of California, San Diego, which is a top-notch university. So I came for the PhD program, and a lot of people ask whether a PhD program is a requirement if you want to have a career in AI. To them, I say that there are two different things. If you want to be an engineer in AI, you don't need a PhD. In fact, PhD may hold you back because you're spending 5 years on this program, and in 5 years the world could have moved away, right? So for being an engineer, if you have a bachelor's and very good grasp of how the technology works, then you're in good situation. Having a master's helps a little bit. But a PhD is only for people who are interested in fundamental research, and research is hard. It's hard because any idea that you think about, most of those ideas have been have been taken. Somebody or the other has done work on those ideas. It's very difficult to come up with new ideas. So overall, PhD is it is an enjoyable experience only under certain circumstances, and I got very lucky with that. First of all, you need to have a very good PhD advisor, which was true in my case, and you need to have a good lab where people are excited about research, right? And if those two things are missing, then PhD would be a miserable experience. So because it's hard in the sense that you have to spend hours and hours trying to know what the state of the art is, how to improve upon it. And most of the ideas, frankly, at least in the beginning that you have, they are either done or not original, right? They're not good. Like there's this joke about a PhD student and his advisor. So this PhD student goes to his advisor's office asking, what do you think about the paper that I just gave you for review? And the advisor says that your paper is both original. It is both, what was the joke? The paper is both original. Yeah, it is very original and good, right? But the part that is good is not original, and the part that is original is not good, right? So it is difficult to come up with original good ideas that are good. So I would say that be very careful about doing a PhD. If you want to do a PhD, that's great, but make sure that you're very well motivated. It's a 5-year commitment, and make sure that you're motivated to take on that commitment. So that's that's the PhD program. But the nice thing about the PhD program is that it is also an extension of your student life. So it was a pleasurable experience in that sense that you form very good friendships. Life is relatively easy. I mean, you still have to work on your PhD work, but you don't have the pressures that come with a job, etc. You can think at your leisure, right? So those are the benefits of a PhD. And if you're interested, go for a top-notch university. And to be in a top-notch university, you must have published something during undergrad. So that's my take on a PhD.
Well, that's great, and such a sweet memories you have. Well, with this, we all are quite excited to know the story of OpenCV library, how the library was born or say developed, and it made a revolution in the computer vision industry.
We actually came out of Intel Labs. It was called CV Lib in the beginning, and one of the founders of OpenCV, Gary Bradsky, was he took the lead. OpenCV, computer vision was very fragmented at that time. In about 1999, 2000, people were publishing papers on computer vision, but there was no way to check their algorithms were correct. So if somebody published a paper, they would not release the code. Releasing the code is something very new, right? It is in the last 10 years that you're almost required to release the code. But before that, nobody released the code. So if you wrote a paper, then it was on other people to understand the paper and implement the code themselves. That was very tough because you could not verify whether somebody has implemented you could not verify whether what they are saying in the paper is correct or wrong. And if you had an implementation, people did not want to give it out because that was their edge. They could write another paper on similar concept, and only they can write because nobody else has access to the code, right? So OpenCV changed that. Inside Intel, Gary Bradsky, he came up with this idea that if we have an open source library where it is standardized, most of the things that you want to do, it is standardized, and then you write algorithms on top of it so that research goes fast. That was the basic premise of OpenCV. Otherwise, you had to write your own canny edge detector. You had to write each and every little thing you had to write on your own. And this was true even when I joined my PhD. I was writing my own computer vision library until OpenCV came along. It became prominent. So that was revolutionary. And for the longest time, OpenCV has grown into a library of 2,500 different algorithms, which is great. You could try these algorithms by just a few lines of code. And today we take these things for granted, right? That, I want to try some code, I'll just download it from GitHub and do it. Earlier, to try a paper, you had to understand the whole paper, implement it from scratch. It was like a 15-day effort to get one little thing tested. So now that with OpenCV and other libraries, those paths have been short-circuited, right? It's been a great thing. And then Intel released it as an open source library in the year 2000. And after that, it switched to, there are many companies who were involved in maintaining the OpenCV library. One of them was Willow Garage. After Willow Garage, ITSEES was a company that started maintaining the OpenCV library. And ITSEES grew from a company of 5 people to a 100 people consulting company, and then Intel bought ITSEES. So currently, OpenCV is again, the core team of OpenCV is back at Intel. So Intel is actually, Intel employees are actually, they form the core team of OpenCV. Now, this was the library until last year. And before that, in 2017 or so, Gary had called me asking me if I wanted to be the CEO of OpenCV. And I was not sure at that time, because I was running my own consulting company. I had started a blog, learnopencv.com. So I was not sure at that time. I declined because I was not even sure what do I do as the CEO of an open source library, right? The main job of the organization was to maintain this library. And I did not have the resources at that time to not be paid for work. Right now, all the work that I do for OpenCV, that is unpaid work. I take $1 per year in salary, right? Because I can afford to do it. I have other consulting businesses and stuff like that. So, but at that time I could not, right? Back in 2017 or so, it was tough for me to do that. So I declined the offer. And the more important thing was that I did not have a very clear vision of where we could take the library. So, so there was this transition at that time that I decided, we will come to the vision. But even, before we jump on to OpenCV, the reason, one of the things that you may not have made the connection is why would Gary even call me to become the CEO of OpenCV, right? So, and the reason is that there is a gap in the story that I did not tell. So first of all, there is this interesting story about when I was a grad student, and I just mentioned that it is very important that you have a good advisor, right? So when I was a grad student in 2003, my advisor was Dr. David Kriegman, and he was asked by Intel to be on a workshop, right, to give a talk on machine learning and life sciences, because he is a big name in that area. And he could not make it. He could have just refused that, I cannot do this, but instead he said that I cannot do this, but here's my student, he's very good, and he will give the talk on my behalf, right? So I end up in this workshop where there are these very big names in computer vision, and I was this grad student, right, giving the talk among these people. And one of the people in that group was Gary Bradsky. And I was a grad student at that time, and there was this informal talk going on where Gary was saying how computer vision is a complete failure. So Gary Bradsky, this was 2003, people in computer vision were they were thinking that computer vision did not live up to its expectation, right? The AI revolution had not happened back then, and people were thinking that, we spent so many years on developing these things and it did not go anywhere, right? It's not commercial yet. So Gary was going on and on about, how computer vision has been a failure. And I was a grad student working in this field. It was very depressing for me to hear that. And I did not see his badge, right? I was going to tell him that, look, you should check out this new library called OpenCV, where they have implemented all these things, including face detection. That was a very big thing at that time. Doing face detection in real time was a huge deal at that time, right? And I said that I was going to tell him that you should go and check out this library called OpenCV, where face detection has been implemented and all these different algorithms have been implemented. And I had the good sense of checking. I had the good sense of checking before opening my mouth. And I checked that, he's Gary Bradsky. And I knew that Gary Bradsky is the founder of OpenCV, right? So I shut my mouth. Otherwise, just imagine, I would have told the founder of OpenCV how OpenCV is a great library. So I did not do that. But that was my first interaction with Gary. And right after my Ph.D., I actually started a company with my Ph.D. advisor, Dr. David Kriegman. Again, that's the benefit of having a good advisor. You have a good idea, and they would actually come out of the university to work with you. And we both had this idea, David and I, to start a company. So we started a company called Site Commerce, which made virtual makeover products. So women could upload their own picture and apply makeup virtually. And that company was just slightly mistimed. It was slightly ahead of its time, because right now that kind of company would be worth $1 billion, right? But we made a few strategic mistakes also. We did not get on mobile fast enough. The mobile revolution was happening. We did not get on Facebook fast enough. So there were a series of business mistakes that we made, because of which the company, we ran the company for 11 years, but the company ultimately did not succeed in any big way. So I was the founder and CTO of that company for 8 years, and then I decided that, okay, I'll step down and do something on my own. And that was the time when I decided that I need to have my own, have my own company, which is not backed by venture capitalists, because I wanted to own the whole enterprise, so that all the decisions were only mine, and then you can have a lot of impact on wherever you want to do. You can take a salary of $1 and nobody cares, right? So it becomes that kind of independence. For me, that was the main goal. So before I left my position as the CTO of that company, I started blogging just because I wanted to help people. So I started blogging, and blogging is it's one of those things that can be very frustrating. When I first wrote my blogs, I think when I had written my 4th blog or so, I went and checked on Google Analytics, and there were 2 people who had showed up on my blog. The first person was me from my computer, and the second person was me from my phone, right? So those are the 2 people who used to read my blog back then. And but I kept writing because I thought that because of my experience that I gained as an entrepreneur in computer vision, I had something to offer. The papers that people were writing, they did not always translate to good engineering, right? So you had to and I thought that I had that insight which will be useful for other people who are starting out in computer vision. And that's why I started blogging. And now, a few million people visit the blog every year. And this is not a lot of time. We are talking about 4.5 years. So there is this compounding effect that happens when you start something new. And that happened with the blog also. But the interesting thing is that when I left my work, when I stepped down as the CTO of my previous company, I did not have a plan. I just decided, okay, it's time that I'll move on, and I'll think what to do about the future. So at that time, I decided that on my blog, I posted that I also do consulting. If you're interested, then contact me. And within 7 days, somebody contacted me that, oh, they have this consulting work. And in consulting, you can charge higher. So with 20 hours of work per week, I already replaced my salary, right? So with only 20 hours of work, the other 20 hours were left, to do whatever I wanted to do. And I decided to invest back into blogging. And then gradually, I grew the consulting company, and now the consulting company has about 50 people. A lot of them are in India, Bangalore. And then it freed me up to do other things also. Like once you have the consulting business going and you have revenue coming in, you could talk about other things. Like one of the things people kept asking me for was, why don't you do a course? And I said, they said that if you do a course in computer vision, we will buy. And I told them that, okay, buy first and then I will do the course, right? So this was my first course called Computer Vision for Faces. And, it was not even a Kickstarter campaign. It was a pre-sale on our own website, learnopencv.com. And based on that, I said, if there are enough people interested, then we will create this course. And before the sale ended, we ended up raising $100,000 before the course was launched. And that gave me enough capital to go hire people, create the course, and so that's how the course was created without actually ever taking venture capital money, right? And then the OpenCV, basically I had some of the professors who knew me, knew that I was doing consulting and I was running this business. So they talked to Gary about, if you're looking for the CEO of OpenCV.org, then Satya might be a good person. And that's how Gary contacted me. So that was, but initially I declined because I did not know where to take this OpenCV.org. But by 2018, I had, I was thinking, what can you do with OpenCV.org? I just don't want to just, maintain a library. What's the joy? It's great. It's a great library. But as a CEO, what do you do? There are already great engineers working on the library. What do? You just go and beg in front of Google and Intel to give you money as donation to maintain the library. That's no joy, right? I didn't want to do that. But by 2018, 2019, I had this vision that was solidifying that OpenCV doesn't need to be about the library alone, right? OpenCV needs to be the best resource for anything related to computer vision. And that's when we changed directions. We came up with OpenCV courses. So the team that I was using for my own courses, we used it to create OpenCV courses. And we did a Kickstarter campaign 2019, where it was the biggest Kickstarter campaign for a technical course. And we raised $500,000 for that, and we launched the courses. So now to become a place which is the best place for computer vision resources, what we wanted is other things that people would be interested in. And I wanted to create an edge hardware, because in edge computing, where all the processing is done on the camera, OpenCV is used by 89% of the people. It is the main library, not TensorFlow, not PyTorch. OpenCV is the main library when you want to do computer vision on the edge. So that's where I wanted to focus. I wanted to come up with some solution, a smart camera that that was interesting. But the problem was that we could not. To build a hardware requires a lot of money. It's a $2 million investment, at least $2 to $3 million dollar investment. So I partnered with this company called Luxonis, who had a smart camera, but it also with a difference, right? They also had this depth capability. So smart camera with depth is almost like human eyes, because you're looking at the scene, and you're trying to see that, oh, there's a chair in the scene, but not only that, the chair is 3 feet from you. And that's the purpose of human eye as well. You're looking at the things, but eyes are also used to estimate depth of things, how far things are. So we'll talk about the OpenCV AI kit in a bit, but just to complete the vision of OpenCV, how it has grown, we have the courses where people can get educated, and then we have Oak, which is a hardware device. But there was a different path we could have taken with Oak. A lot of large companies which manufacture smart cameras, they were interested in OpenCV, in this smart camera, and we could have just worked with these large companies to make smart cameras. But my goal has always been to spread AI education, right? People need to be educated about this stuff. Otherwise, I want to build the developer community around the hardware. And that is why we did the Kickstarter campaign. A lot of people think that we did the Kickstarter campaign to raise money for the hardware itself. And that's actually not true. The hardware was already done. We did not have to raise money for the hardware. The main reason we did the Kickstarter campaign was to bring down the price, right? The hardware sells for $299. The Kickstarter campaign gives us an excuse to reduce the price, because if you reduce the price, our our vendors will, the people, our current clients would say, "What are you doing? I mean, you just reduced the price. We bought it for $300, and now you have reduced it to $149." So we could not. So the main goal of the Kickstarter campaign was to reduce the price, because you could say that it is a Kickstarter campaign, we are going to add more features. But by reducing the price, we are increasing the developer community, right? I'm very interested in companies who are going to build smart cameras around it, but I'm also very interested in small developers who can buy this kit and start developing AI solutions by themselves. And $300, it's a bit too much, if you want to look about the global audience, not just the US audience. If you think about people in India, developers in India, if you want to make it affordable for them, then you have to bring down the price as much as possible. So like $149, which is the current Kickstarter price, it may still look a little bit higher, but if you think about it, it is slightly above the price of a high-end webcam. So it is still very affordable, and it is very close. We almost make no margins on that. The price is very close to what it costs us to build. But the main goal with this Kickstarter campaign was to make it accessible to as many people as possible. And right now it's about more than 4,500, probably close to 5,000 people. Now think about what the possibilities are, right? You have a developer community of 5,000 people, and what can you do with that? It's amazing. They will help each other out. They will bounce off ideas. We'll also create a forum. We'll also create a course around it. So it's not just somebody gave you this hardware and you're locked in your room trying to figure out the documentation. We'll have a very active community around this hardware. Now, let me just finish the vision of this, OpenCV, and then we will talk about the next topic. Then the other thing that we are coming up with very shortly is OpenCV forums. I need to figure out, how to make it free. So right now, right now there is this forum on OpenCV. It is called answers.opencv.org, but it's very difficult to get answers there. It should be called questions.opencv.org, because there are a lot of questions but very few answers. And we want to change that. We want to create a forum where some of our own developers are answering questions. There is a lively, active community, but also our developers are answering questions. So that I'm trying to figure out how to do that, but it's coming soon. The other thing we are doing is, OpenCV consulting services. If there are companies who want consulting services, then they can hire us. And that is being done through the for-profit arm of OpenCV, and that's called opencv.ai. And the final thing that we are doing is a model zoo. This has not been announced yet, but this is going to be very exciting. So suppose you are an independent developer and you have developed an AI model, then you can put this AI model in our store, and we will produce a web API. You don't have to do anything. We will create a web API around it so that people can try your model and use it. And if it is a paid model, that's also feasible. We'll also have a paid option. So you can get paid for having your model on this model zoo. And the goal here is to go after the long tail. The Googles and the Amazons of the world, they are solving specific problems. What we want to do is solve the long tail. If you have built an AI model that only 1,000 people in the world are interested in, you can put it on our AI zoo, and those 1,000 people will be able to use it. So it's the long tail that we are going to create. So that AI model is also marketplace is also coming soon.
Oh wow, what a vision! Fantastic. Uh, with this, I would like to appreciate efforts for developing OpenCV AI Kit. Big hit today, and thanks for OpenCV Forum initiative. Hope so it will be live soon. I would like to go for the next question. This is the most asked question on our forum, and question is that how to get started with the computer vision.
So go ahead, sorry.
Yes, sir. That is the question.
Yeah, so to get started in any field, nowadays it is relatively easy. The first thing you should do is to even understand, whether you're interested in computer vision or not. Does it actually make you excited? And for doing that, you should not start by paying anything. Go and check out our blog, learnopencv.com, and there are a lot of tutorials, free tutorials around there. And there are several computer vision blogs that are very good. There is PyImage Search, there is Machine Learning Mastery. So all these blogs, they produce free content. So consume all the free content first, and then decide for yourself whether it even makes sense for you to be in this field, right? Don't be in this field because it is cool. Be in this field because it is exciting to you, right? Personally exciting to you. So I would say that the very first thing is learn. If you don't already know Python, learn that one language, Python programming language. It is a relatively easy language to learn. And once you have done that, you should take all these free, take these free resources that are available, blogs, read blogs, watch video tutorials, and start with small examples, right? You decide that, okay, I'm going to learn this small example. Let's see how I can do this small thing, right? And write code around it. Spend a day, 2 days to write that small piece of code and try to fully understand what each part does, right? And it is perfectly fine to start with a code that you're copied. You take code from my website, learnopencv.com, and try to modify it. That's fine. It's people learn by copying first. You copy somebody else's code and try to modify it and see whether you understood something or not. Suppose you come across a particular function, let's say for edge detection, you modify the parameters and try to understand what these parameters do, right? And take it slow. There is this saying in the military that slow is smooth and smooth is fast, right? So things that you do slowly and with deep conviction, try to make things where you understand the fundamentals, don't rush, but make steady progress, right? The effort should be huge, but the progress can be slow. So always remember this. You have to put consistent effort, and even if the progress is slow, do not worry about it. Progress it is a non-linear curve. Initially the progress is very slow, and suddenly you will see that you've started understanding things like that very quickly. So yeah, so that's my advice, that first start with these blogs, get the code, modify that code so that you make small changes, and once you have understood enough, then try something more ambitious. So little steps at a time, but do take those steps. You cannot stop. Take those steps consistently. And once you have a grasp of things, right? Once you are confident that you like this field and you are able to try various things, then you may want to have structured education, right? Where you may want to ask, you may want you may want to learn in a structured way, right? Tell me this, tell me this, tell me this, and then you do a project, etc. And for that, you can come to our courses and start learning, right? OpenCV has a series of 3 courses. The first one is called Computer Vision 1, which is an introductory course in computer vision. It's an excellent course, and we give the course in both C++ and Python. So Python is an easier language, and that's what you should try first. But once you have tried that, you should also look at the C++ version, because sometimes when you want to write performance code, the code which is for high performance computing, then you have to go to C++. And the beauty of OpenCV is that you can try both C++ and Python. The second course is Computer Vision 2, which is focused on applications. And the third course is Deep Learning with PyTorch. So deep learning is this new technique in computer vision, very, very effective, and it solves a wide variety of problems. So we teach deep learning with PyTorch, and that's another course you can take. There are other courses coming soon, like deep learning with TensorFlow will also be released soon in the next few months. So those are the courses you should take. But I cannot emphasize enough, don't take the courses without trying out the free material. First, try out everything there is to try out for free, because it will not only tell you whether you are interested in the field, it will also prepare you for the courses itself, right? You're already prepared for the courses. And slow progress is just fine. You do need to put in the effort. The progress can be slow. Don't worry too much about the progress.
Very well said, sir. I mean, it's quite motivating for us to learn. I mean, in AI, you have to learn a lot of things. You have to read a lot of blogs. You have to read a lot of research papers. And after one point, it's get quite impatient. And it's like you get impatient, and sometimes people give up. But that is the whole mantra you have given, that
right.
Be patient,
right.
Go slowly, and you will learn things. I mean, don't worry about the progress. Horizontal and vertical process, that's the whole funda. Thank you so much, sir. So
there's one more thing. There's one more thing I want to add. So people say that, oh, they don't have time. They have such busy lives and things like that, right? And I have 2 things for them. A lot of people ask me, I don't have time. How do I? And I ask them, so how much TV did you watch, right? And they would be like, 1 hour a day. How could you find 1 hour a day for television, right? Then how much time did you waste on social media? And another hour would come out of that. And then finally ask them, at what time do you get up? And the answer is usually 7:30 and things like that. I wake up, most of the days, I wake up at 4 a.m. Okay. I'm at work by 5 a.m. Okay. And, I can put in, I can be on social media and do whatever things I want. I can waste a lot of time. But because I wake up at 4 a.m., I will still be ahead of most people in terms of the amount of work I put in. So by the time it's noon, by the time it is noon, I have finished work that is, most people do that kind of work, right? I've already done by the time noon happens. So I think that, and people, you have to put that effort in. You cannot say that you cannot have 1 hour of television every day and not 1 hour of AI education, right?
Yeah, yeah. So, well, next question is that what is OpenCV AI kit, and is it gonna compete with Raspberry Pi, or is it gonna interface with Raspberry Pi?
OpenCV AI Kit is the first hardware that we have built in collaboration with a company called Luxonis, because as I said that OpenCV did not have the resources to pull off a hardware. So we collaborated with another company called Luxonis who had this product, and we wanted to enhance the product in several ways. First of all, we wanted to create beautiful software around it, right? It is not just their hardware was already good. We wanted to enhance the hardware, but we also wanted to create very easy to use APIs. Now, if you take any, accelerator, neural accelerator on the market, it takes some effort to actually get it working. You may spend half a day with a Movidius neural compute stick, right? But our experience, what we wanted to provide to the users was you plug in this smart camera and you're ready in less than a minute, right? So we worked with Luxonis to make that happen. And when they first shipped me the first, the prototype, and I plugged in, and that's exactly what I did. I said that this has to work within less than a minute, and it was, about 30 seconds.
It worked?
Yeah, it worked. The installation, everything was in 30 seconds, right? So it worked.
Wow, that's fabulous.
Yeah. So that is what we wanted with Oak, and it is actually a smart camera. So it doesn't compete with Raspberry Pi. Raspberry Pi is a computer, and Oak is a smart camera which attaches to this computer. You can attach Oak to a Raspberry Pi. You can attach Oak to your own computer also, right? So in that sense, they don't compete. They are, they work together. What Oak provides is, inside it is Intel's Myriad X chip, right? So you have this camera. From the camera, the frame comes in, and whatever model you have loaded on the Myriad X chip, that gets executed. And you could have a chain of models also. So we have created a pipeline where you could have object detection. You could have, say, face detection. On that face detection, you're running another model which does landmark detection. And on that, you're doing something else. So you could have a pipeline of things that this smart camera can do. So the frame comes in, it goes into the Myriad X chip where all these, let's say object detection is executed. And then that detected object passes on to the Raspberry Pi or the host that you have connected. Now, keep in mind, all this processing happened without touching the host. Only the final results you get on the host, which means that the host is free to do other things. The processor is not being used at all to do all these different, heavy duty things. Even in case of, say, Intel neural compute stick, etc. What happens is that you have a camera. The host is responsible for grabbing the frame and then sending it to the neural compute stick. So it is in the path, and that consumes resources, right, of the host. In our case, the host is not in the path. The host comes in the end. It just receives the final information, right? Not only that, this also does depth in real time. So the Oak camera has two additional cameras. It has the RGB camera, but it also has two additional cameras for doing depth analysis. And it does stereo vision in real time. So not only can you get, there is a person, it can detect that there's a person, but also the location of the person. That's why it's called a spatial AI solution. And if you were to actually build this kind of solution with existing parts, that will be $700, $800 and a lot of trouble to get things in sync. The frame that you receive from the depth camera should be in sync with the frame that you receive from the RGB camera and things like that. All that hard work has been done for you, using this oak kit. So it's very powerful. It is something that, many researchers would be interested in. It is something that a lot of companies would be interested in. But more importantly, once you get the knowledge of how this thing works, you get a sense of how computer vision works on the edge. Most of the things that you learn today, they tell you how to deploy computer vision on the cloud, right? You have a GPU, a massive GPU, and you are able to do all these things on the cloud, which is interesting, but we want to deploy it to the edge where this thing doesn't even go to the cloud. So the privacy is protected. You can also create a firmware, where it is locked, so the frame cannot leave the device. Technically, you can do that. So privacy is protected. That's why edge computing is so important, right? Like there is a vacuum cleaner by Dyson, and it uses computer vision. And you would be thinking that, oh, how can anybody let a vacuum cleaner in their house? There is a privacy concern with a camera. And the fact is that it is locked. The firmware locks the hardware so that you cannot send any frame outside the device. So that way they protect the privacy. And these things are important to learn when you want to enter the field of computer vision. There will be a lot of people who would know how to train things on the cloud, etc. But you don't compete with people head on, right? When you're competing, I like to say, I tell my kids this thing, that how do you beat Roger Federer? How do you beat Roger Federer? The answer is that you invite him to a game of chess, right? So you play from your advantage. You don't play what is the strength of the other person. And a lot of people are building a lot of good strength in general AI. But if you focus on specific things like edge AI, which is a huge market in itself, but most people do not focus on that, right? Because they are focused on how to train using a GPU, etc. But if you have this additional edge, there's a pun intended there. If you have this edge of edge computing, then you are ahead in the game. When you're in the job market, you say that you are able to deploy these things on an edge. You have built this hardware, you have worked with this hardware that gives you an additional edge that normal people who are just taking code from GitHub and trying something will not have. And you also have a appreciation of how to work with hardware and software, right?
Yeah. With this, I would like to move for the next question. And the question is that, what are the prerequisites for the artificial intelligence?
Today AI has become so easy, so accessible in some sense, that if you know one programming language like Python, then you can do a lot in AI. There is the job market is such that there are a lot of people who are looking for AI education, but they do not. There are a lot of people who are looking for AI professionals, but there are not enough professionals. So if you have a working knowledge of say Python, then you can get started with AI. But if you want to get deeper into AI, if you want to get into AI research, then that's a different issue. Then you need to have a very strong mathematical background, and that's a prerequisite. But other than that, if you think about deep learning, the requirements are not much. If you know a little bit of linear algebra, you need know a little bit of calculus and stuff like that. It becomes very accessible. So it's not a lot of math, but you need to know some of it.
Next question is that, is it possible to add artificial intelligence to the stock market?
So the stock market is, it is one of the toughest things to model using AI. There are a lot of companies that are trying to crack this nut, And of course, there are inefficiencies in the market, and using AI, you can find those inefficiencies and benefit from them. But this is a game that people with deep pockets play, because it's not just it is not just what algorithms you use. It is also how much computational power you have. It is a timing game, right? And people in the stock market, the big companies in the stock market, they fight for nanoseconds, microseconds of advantage. So, for example, there is this facility in the, I think, New York Stock Exchange, where these big companies are all connected very close to the main computers. And the way they have negotiated it is that even the length of the cable that connects them to the main computer is exactly the same for all these high profile people. So even microseconds, sometimes nanoseconds counts when you are doing this analysis. So it's a brutal industry. The stock market is extremely brutal, and a lot of people have got burnt in it, and it will continue. It is one of those lucrative things that people want to apply AI to, and some of it can be applied, but it is also very easy to lose money in the stock market. So be very, very careful if you enter that field. A lot of very smart people have burnt their hands in it. The best example of this is this company called Long-Term Capital Management, LTCM, which had 2 Nobel laureates in its founding team, and they went bankrupt because the calculations they had made, they did not take into account how the market could change dramatically. So just a word of caution that it's extremely difficult to consistently make money in the stock market without increasing your risk. You can take huge amounts of risk, and if you're lucky, you can get a lot of money, but it is a difficult game to play. And there are big players with huge number of resources who are already playing this game. So yeah, that's my word of caution on the stock market. Another question by Pramath is, what is the future of computer vision? So that's a very difficult question to answer in that sense. But what I can say is that computer vision is going to permeate all industries, right? It is like Professor Andrew Ng likes to say that AI is like electricity. When electricity was first invented, it was applied for lighting, right? Light bulbs and stuff like that. But very soon, it was applied to pretty much all the industry. It transformed multiple industries. And that's exactly how computer vision is also going, right? We started with some face recognition kind of application, but now wherever you have a camera, you will be able to apply computer vision. And camera is the cheapest kind of sensor. If you think about it, the cheapest forms of camera, they are, when they are embedded in these devices, they could be the cost could be as low as $2-3, maybe $5 kind of thing. So what we are looking at is a huge number of cameras, which are very inexpensive, applied to a huge number of industry. So the future is in breadth of computer vision, to the amount, the kinds of problems that computer vision will be applied to. That's just huge. It's like, we have given eyes to the computers, and they want to solve all the problems using computer vision.
This is the last part of the session now, and on the last mile, what advice or say suggestion you would like to give us, Satya sir?
I just want to say that stay at it. It may look hard in the beginning, but keep at it. Make progress, and put in the effort. Even if the progress is small, don't worry about it. It will finally come together. And think about the nonlinear curve always. Nothing happens in the beginning, and then things take off spectacularly. Join our mailing list. We publish a blog post every week, so that will get you interested in the subject, right? You will get. We also publish on a variety of topics, and it is at many different levels. Some of them are for beginners, some of them are for intermediate, and occasionally we also produce for experts, like who are very good. They can also benefit from the posts that we write. So that would be the first thing. And even though the post may not be targeted towards you, you should still read the post, because it familiarizes you, right? You may not understand everything, but learning is an iterative process. The more, suppose you learned about this new concept called optical flow, right? And you don't know anything about it, and you read the first post about optical flow, maybe you got 50% out of it, right? And again, after say a month, you read another post which again talks about optical flow, and then it refines your understanding of what this thing is. And gradually you become so familiar with the concept that when you read the actual optical flow paper or something like that, you have a very good grasp, you have a very good ground to start with, you have a solid foundation to start with. So I would suggest that go join our mailing list and at learnopencv.com, follow our blogs. There are other blogs also you can follow in computer vision, and that could be your starting point. If you don't know any programming language, learn Python first. That really helps. And keep in mind that this is a non-linear process, right? When I started blogging, 2 people used to show up in the blog, as I said, but now millions are showing up. And it's not a linear curve. Doesn't go like that. For the longest time, nothing happens, and then you suddenly start seeing results, and those results can be astonishing, right? It will surprise you how quickly you go from being an amateur to pretty good place where people will hire you for your services.
In the first half, session got cancelled due to some incidents happened on my side, but finally, after all, this session is happening today. So special thanks to Satya sir, and thank you so much for watching. I'll see you in the next one. Bye bye. Take care.